We're always told that to make AI fair, you have to make it blind to things like gender or race. But what if that approach actually makes the problem worse? Today, we're going to decode how bias can sneak in through the back door, using data that, on the surface, looks totally neutral. It feels like a paradox, doesn't it? I mean, if you build an AI for loan applications and you specifically tell it to ignore gender, how on earth could it still be biased? Well, believe it or not, the answer is a huge yes, and we're about to dig into exactly how that happens. Okay, so here's our game plan. First up, we'll tackle what's called the proxy problem. Then, we'll see why the usual ways of checking for bias just don't cut it here. After that, we're going to unpack a really cool new tool that explains the why behind an AI's decision. We'll uncover a hidden clue in the data itself, and finally, we'll get to a point where we have to question what fairness even means. Let's dive in. All right, let's jump right into our first section and really get a handle on this core issue. It all comes down to how these seemingly innocent little data points can carry some seriously hidden and often problematic meanings. So, this is the big idea. Proxy discrimination. It sounds complicated, but it's not. Think about it like this. A zip code seems totally neutral, right? Just a number. But if that zip code is super correlated with, say, race because of how cities were historically built, then using that zip code in a decision, well, you're basically recreating old biases without even trying. The zip code becomes a proxy, a stand-in for race. The AI isn't trying to be discriminatory, but the result is exactly the same. Okay, to make this less abstract, let's follow a real case study from something called the German credit dataset. Meet Yaya. He applies for a loan, the AI gives him the green light, and hey, the model was specifically programmed not to use his gender in its calculations. So on the surface, everything looks perfect. But as you've probably guessed, there's a lot more going on under the hood. Okay, so if you're the person whose job it is to check for bias, an auditor, how in the world do you even spot something like this? That's the problem. The standard tools, the usual checklist, they're just not built for this kind of sneaky hidden bias. This slide, I think, really lays out the whole challenge perfectly. A standard bias audit, that's on the left, asks a pretty simple question. Does the code explicitly use gender? And for Yaya's case, the answer is a clean no. So case closed, right? Not so fast. The proxy bias audit, over on the right, asks a much more clever question. Do other features in the data indirectly act as a stand-in for gender? And suddenly, the answer isn't so simple anymore. It's maybe, and we've got to dig a whole lot deeper. So, how do we possibly answer that much trickier question? Well, this is where some new research comes in. A new kind of diagnostic tool has been developed, and it's designed to do one thing: explain the real why behind any single AI decision. The heart of this new tool is something called an abductive explanation. Now, don't let the fancy name scare you. The idea is actually pretty intuitive. It's a way to find the absolute smallest set of features, the bare essentials, that were enough to guarantee the AI's final decision. It's like it strips away all the background noise to find just the crucial ingredients that made the cake. So how does it actually work? Well, it's basically a process of elimination, and it's really clever. You start with everything you know about an applicant. Then you pull out one feature and ask the AI, hey, did the decision change? If the answer is no, if the decision stays the same, then you know that feature wasn't essential. You can toss it. And you just keep doing that over and over until you're left with only the stuff that is absolutely critical for that outcome. That is your abductive explanation. Okay, let's bring it back to Yaya. After running this process, the researchers found his essential ingredients. The AI said yes to his loan because of this very specific mix: his age, the fact he had no savings, his credit duration, his marital status, single, and that the loan was for a car. Now, here is the crucial part. Look at that list. What's not there? Gender, right? So it seems like we've just confirmed the AI is unbiased. But have we? This is where things get really, really cool. That explanation we just found, it's only half the puzzle. To really understand what it means, we have to add one more secret ingredient: real-world context. The researchers call this background knowledge. And this isn't about the AI's code or its programming. It's about these unbreakable rules or patterns that are hidden inside the real-world data the AI was trained on. Seriously, think of it like finding the secret recipe book for the dataset. It reveals all these hidden connections between the different data points that you'd never see otherwise. And when they dug into the background knowledge for this particular dataset, they found the smoking gun. It's right here on the slide. It turns out that in this specific collection of data, a single person applying for a car loan is always male.
It was literally impossible to find a female applicant who was also single and getting a car loan. That specific combination of features only ever belonged to men.
And suddenly, it all just clicks into place. Remember Yaya's essential ingredients? The explanation included single and car loan. Well, because of that hidden rule we just found in the data, that combination is a perfect proxy for being male. The AI didn't need to see his gender in the code. It found it anyway through this back door. The decision was, without a doubt, biased.
So the decision is biased. Case closed, game over, right? Well, not quite. This is where this whole framework introduces one last, really crucial twist. It makes us ask a tougher question. Just because the decision is biased, does that automatically make it unfair?
And here's the part that might just bend your brain a little. The goal, according to this research, isn't about treating everyone identically, because in the real world, different groups of people might show their qualifications in totally different ways. The real goal is fairness, which means ensuring that people who have an equivalent underlying aptitude for something get treated equivalently.
So what's aptitude? It's defined as that core abstract quality you're actually trying to measure. For a loan, it's not, is the person single or do they want a car? It's, are they financially responsible? The data points we see, like marital status or loan purpose, are just the signs or the manifestations of that aptitude. And because of societal patterns, those signs can look very different for a man versus a woman.
So this slide lays out the ultimate fairness test. On the left, you've got Yahya's explanation. The combination of features the AI learned is a sign of good aptitude for men in this dataset. The real trick then is to find the equivalent set of features that signals the exact same aptitude, but for a woman. And based on the patterns in the data, that counterpart explanation might be something like being not single and getting a loan for something other than a car. So the final million-dollar question is, does the AI also approve that application?
And the result here is absolutely fascinating. For this specific AI system, the answer is yes. It does grant a loan to the female applicant with the equivalent or counterpart explanation. So let's put this all together. The decision for Yaya was definitely biased. It leaned on a proxy for his gender. But it wasn't necessarily unfair, because the system treated an equivalent woman in the exact same way. In a weird way, the bias was needed to achieve fairness across these different groups.
All right, let's wrap up with the key takeaways from all this. First, AI bias can be hiding in plain sight through what we call proxy variables. Second, to find it, you have to look for the essential reasons behind a decision using something called an abductive explanation. Third, real-world context or background knowledge is the magic key to unlocking what those reasons truly mean. And finally, and maybe most importantly, true fairness isn't about identical treatment. It's about making sure that equivalent underlying aptitude gets you an equivalent outcome.
And that leaves us with a really provocative final thought to chew on. For decades, the ideal of fairness has been all about blindness, being blind to race, to gender, to all these protected things. But what if this research shows that that's just the wrong approach entirely? What if, to build truly fair AI, we have to stop pretending to be blind and instead start to actually see the differences between groups and account for them intelligently? What do you think?